What's going on today? We're going to talk about the ZeroLogon vulnerability. The ZeroLogon vulnerability affected Windows Active Directory, and this vulnerability allows an attacker to log into an Active Directory domain controller without any password after resetting the password to a null value. So we're going to go over the concepts behind this vulnerability, the proof of concept, and then we will look into how to demonstrate the exploitation of this vulnerability on a machine from TryHackMe. So in this video, we're going to go over the lab and proof of concept, of course, the concepts, in addition to the concepts. So basically, let's get started. So first, the vulnerability takes advantage of the Microsoft remote authentication, namely the Netlogon. So basically, you can see here, when a client authenticates to a server. So the client here is a Windows domain joined machine. Okay, the server here is assumed to be a Windows Active Directory domain controller. So when the client logs in, when you log in to the server, which is an Active Directory domain controller, the whole process is called the session negotiation key. How the keys are negotiated, and how the authentication or the Netlogon remote protocol takes place. So the logon vulnerability takes advantage of a weakness in this mechanism. So basically, as you can see here from the figure, the client, which is supposed to be, as I said earlier, a Windows domain joined machine, creates something called the net server request challenge. The net server request challenge contains the name of the domain controller, contains the target device, which is also the domain controller, and a value of 16 bytes. This value is all zeros, and that's the weakness. Now, in the second step, the server responds back with net server request a challenge. The net server requested challenge will be generated with its own set of bytes. So basically here the client created a value consisted of 16 bytes of zeros. And the server here, when they respond back, it responds with another value consisted of 16 bytes of zeros. Now, then the client will ask to request to authenticate, as you can see here. So the challenge is completed. Next to authentication, the client sends net server authenticate. So the client here will compute its credentials and try to authenticate to the server with the Netlogon method. So basically, there are a number of requirements for the client to create before it sends the net server authenticate. As you can see here, how the process goes. You can read more through this page. But in a nutshell, when the server responds back, it responds with the same way the client, with the same way of creating the credentials. So the client has created and computed the credentials in the request. The server will do the same with its own parameters, and then it will compare. If the values are the same, it will grant access. So the ZeroLogon vulnerability takes advantage of a weakness in this mechanism. The weakness here is that starts from step here 3. So when the client starts computing its credentials, the Netlogon, tries to guess the initialization vector. If I can explain that simply, the initialization vector of the encryption. So it tries a set number of times until it guesses that initialization vector, which contains the plain text credentials. So basically, the weakness here is that the value used for the exchange of keys and authentication consists of zeros. So when the client, or when the exploit, or the exploit developer, let's say, or the exploit tries to guess that initialization vector, it takes advantage of that fact that the initialization vector consists of values of all zeros. So it tries to do the same. I hope this explanation was a bit simple. but you can go through the page and read through the mechanism of how the authentication occurs between a client and a server using the net remote log on or Microsoft Netlogon remote protocol. So theoretically, that's how it happens. Now we're going to go over the proof of concept or the exploit code, going over the lines written there to try to understand how it operates. So you can find the exploit code in this page. So basically this is the exploit code. I'm going to go over the exploit code and explain it in my own editor. So here it is. So as you can see, the first 5 lines, it imports the InPacket library, importing the required models for the InPacket. So here we import the required modules from InPacket because InPacket is used to just conduct the attack. Next, I'm going to skip this, go to this line. So this line, we define a variable called maximum attempts equal 2000. And here I have a put a comment for you. The maximum attempts denotes the maximum number of retries for the ZeroLogon vulnerability during the Netlogon authentication. So here we have 2000. It means that the exploit code or proof of concept will try 2000 times unless it resets the password of the domain controller. So let's stop here and go to the very below here. Okay, so we start the main function. The main function starts here, and we check the number of arguments passed to the exploit. So basically, when you run this exploit, we're required to pass a number of arguments. Among these arguments, we have the name, of course, of the exploit, and we have the DC name, DC IP. DC name is the name of the domain controller, which is the target. DC IP is the IP address of the domain controller. And then if, as you can see here, if this user has supplied less than 3 arguments, it will print the help menu. Or if the client, the user has provided the right number of arguments, as you can see here, the arguments are passed to 2 variables, DC name and DC IP respectively. DC name here equal to DC name or stripped dollar. Dollar sign is stripped from the domain controller name to be able to use it properly in the code. And then we go to this function, perform the attack. Perform the attack is a function that takes 2 parameters. The first one is the domain controller name, domain controller IP, and again DC name. Let's go to that function and see how the attack happens. So we go up. Okay, define perform attack. So we pass the domain controller name to a parameter name called DC handle, DC IP, and target computer, which is the computer name. Here is the domain controller IP. Print performing authentication attempts. Okay, here we set a value which is only, a variable which is only used to keep track of progress. So basically, we check this variable regularly to monitor when the successful authentication is realized. So basically, we start the for loop. The for loop starts at 0 and ends with the maximum attempts variable that we have seen up here, which is 2000. So we're going to try 2000 times, and then we put the value. As you can see, we have another function called TryZeroAuthentication. The TryZeroAuthentication will perform the what's supposed for the exploit to do, and it assigns the value to the variable that we have defined earlier to keep track of the progress. Now, if RPC con equal none, none means that if the RPC none, which equals to the authentication results from this function, if it equals to none, it means that it is invalid login attempt. It prints just equal, right? If it doesn't equal to none, or if the login is not invalid, then it will print out that the attack has been successful. And if the value of RPC con neither invalid login attempt or anything else, it will print that we have tried 2000 times, but the attack failed and the server is not vulnerable. Let's go now to try zero authenticate to understand how things work. So go up, try zero authenticate. Again, try zero authenticate takes the parameters we have agreed upon, DC handle for the domain controller name, DC IP, and target computer name. Now, binding, here it starts to connect to the domain controller. And let's go down. Okay, this line. So nrpc.net server request challenge. Now here, the exploit code is acting as a client, right, who is requesting authentication. If we go back to the diagram here, we see that the client first sends a net server request challenge. And this is exactly what the exploit is trying to do. Send net request server challenge with the parameters it has, which is DC handle, domain controller name, target computer, of course, the RPC con, which is the variable that keeps track of the progress, and we have plain text. Now, plain text here is defined as zeros, ciphertext is defined as zeros. And why zeros? Because I have said earlier that when the client computes its credentials in the first step, right, it computes the credentials, when it asks for the requested challenge, it sends a value of 16 byte of zeros, right? That's why here we mimic the value, we mimic the process by also defining zeros here in the request. Now, here we have a try and error loop. So we have server authentication, which will contain the server response after we authenticate. Okay. Now, as you can see, it takes the same parameters, RPC con, handle, target computer, and here we have Netlogon secure channel, computer name, ciphertext, flags. Okay. Now, what's going to happen? After the server replies back with a login response, it will store the value in server authentication, right? Now, if the server authentication code was equal to 0, right, it means that the authentication has succeeded, and it will return the value of RPC con, which will equal to the entire, which will equal to the server response, okay? Except, and here we have error handling. Let's go back. Assuming that we received a successful authentication, we will have the value of RPC con equal to 0. And here, as you can see, if RPC con equal to none, which is not, it will go here and print that DC can be fully compromised by a ZeroLogon attack. That's simply how the exploit code works. Now, you can take the same exploit code and go to Kali machine and perform live testing for the ZeroLogon vulnerability. I'm going to open a new tab or view, split. TryHackMe. Okay, so sudo mx directory, name it 0. Okay, sudo nano 0 or it's better to download these scripts from its original source. I prefer this, so let's take so here to so we're moving the exploit to the directory of the lab, cdcpe. So this is the exploit code. Now, before starting the exploit, of course, you will conduct nmap scanning. against the target. So sudo mmap oops. So what do we have here? Oh, I'm not connected. Let's connect to the network. Now we can scan the targets. Now from the scan, we will extract some of the answers for the questions that I'm about to show you now on the TryHackMe room. After that, we will try the exploit live on the machine. Okay, so from the scan, it is very clear that this machine is running an Active Directory domain controller. You see we have Kerberos, we have NetBIOS, and this is information about the domain controller, the target name, on the live, the NetBIOS name of the computer, domain name, and the DNS computer name. All of these information, we will use them in the while we run the exploit. So let's now run the exploit, okay, and see what we will grasp. Sorry. Sudo python 3 ZeroLogon tester.py, and then we type the domain controller name. In this case, it is, as you can see, it is the NetBIOS name, DC01, and the IP address. So now it is just doing what we just explained in the exploit code or the proof of concept. For 2000 attempts, it will try to log in and perform a password reset for us. So we can just next log in with secrets dump from packets to dump all of the passwords or password hashes for the existing users. Okay, while the exploit is running in the background, let me answer the questions, some of the questions, as much as we can. So, what is the NetBIOS name of the domain controller? The NetBIOS name is listed in the nmap scan, which is DC01. What is the NetBIOS domain name of the network? So the NetBIOS domain name, it is here, hololive. What domain are you attacking? Very clear, holo live local. What is the local administrator's NTLM hash? How many domain admin accounts are there? What is the root flag? Now, the rest of the questions are to be answered after we reset the password of the target. Let's see here. Till now, it is trying. Success, DC can be fully compromised by a ZeroLogon attack. So this means that we can successfully exploit the target. Now, next we will exploit it by changing the password. So let's see how we do that. So head back to InPacket, see if we have ZeroLogon. So from this page, as you can see, we will download the exploit and actively change the password. So here, cd-back sudo git clone cd ZeroLogon, and the same, we will run it the same way we run the tester. This is 01 and the IP. So they're looking similar, the same way actually, but this exploit takes things further and reset the password or change it. So after changing the password, we can use secrets dump from InPacket to dump the NTDS database. So we can see everything, we can see all the password hashes. Sudo Python 3 secrets dump. Okay, the options. So I will provide dash just or maybe dump this with the help menu. Help. I need sudo to display the help menu. Ironic. Okay, let's see here. So we have to provide some parameters. DCIP, target IP address. Here we'll provide the no pass so that the server will not ask us for password. We will provide the -just-dc to dump the NTDS DIT data, NTLM hashes, and keyframes. So pretty much we got this figured out. Okay, sudo python 3 secrets dump -just -dc -new -pass. Okay, then domain controller name dc01, and we need the backslash. So okay, the $sign, and $sign just provide at and the name of the IP address. So you can try this exploit at this URL. Let me clone this one. So far, we have seen that the target is actually vulnerable, but actually we can't just correctly exploit it. That's why the login failed here. cd back, cd, okay, sudo git clone, cd to 0, log on, and then we pass this. Again, DC01. ZeroLogon successfully exploited, changing password. So I'm assuming the password has changed now. Let's try to launch secrets dump and dump the credentials. Is loaded to the bad username or authentication information. Well, sudo, let's see if we can play again with the parameters. So no pass, just DC. So here we have, I think, oh, instead of 0, this is the correct one. Okay. So pretty much it worked now, and here we got all of the credentials. Now, what is important to us is let's see the questions. What is administrator's NTLM hash? Let's go up. Administrator, and this is the NTLM. Oh, I copied the wrong one. Okay. Second part. How many domain accounts are there? So, as you can see, how many domain accounts? Let's check it out. So we have first account, the second account, and pretty much the rest are not considered as admin accounts. Why? Because they are not prepended with A. A means admin. In other systems, it could be E or something else. So we have 2 in total. What is the root flag? So for the root flag, we will use the evil winrm to log in. So let's take the hash first. Evil winrm. Do I have it? I don't have it. Let's install it. Okay. So we take this. We're going to the packet tools now. So we see the out of it. And sudo git clone. And we have it here. Okay, let's copy back the hash. Evil winrm.rb. Okay, so dash u administrator provide the NTLM hash. and the domain controller IP address. So get back, just remove the Ruby. And now we have got access. So cd back, dir, cd desktop, dir, and the root flag should be here, type. Okay. All right, now you've got some questions here about the proof of concept and additional concepts about the authentication and the weaknesses. You can just answer them by reading through the explanations here. So that's it for the lab, and I hope you enjoyed this part. See you in the next video.